Hello friends, welcome back to my channel. So in this maintenance channel we have studied various things about DG sets, compressors. So now today we will learn some basics about the low tension circuit breakers. So we will know what is low tensions and what are the types of low tension circuit breakers, LT circuit breakers. There are two types, LT and ST. ST is high tension, LT is low tension. So we will now, because in general industries we are using the low tension. ST is our just the main connection where PCB is generally used, but for regular maintenance, we use the low tension circuit breaker. So we should know what is that, what are and various types of low tension circuit breakers. So what is LT? Low tension system voltage up to 1000 volt of AC is termed as LT. Common voltage levels are 230 volt, 415, 440 and 690. In India generally we deal with 230, 415, either 415 or 440. This is plus minus 6%. Now purpose of circuit breaker. What is the purpose? Automatic switching device means sometimes it is automatic, sometimes there is manual. Switching means it's on and off just to protect your further connected devices. Protects Circuit breaker protect against overload current, short circuit current, earth fault or leakage current. Overload means some overload happens, so it just strips to protect your device like motors, cables. Short circuit, if any short circuit happens and sudden rise in current occurs, then also the circuit breaker trips. If any earth fault occurs, cable damage, so to protect the human working, it trips the circuit breaker and the leakage current. Now introduction to LT circuit breakers. Why circuit breakers instead of fuse? We may use fuse also. Earlier we were using fuse only. Now in some cases we still use fuse. So but most of the areas we use now circuit breakers. So why circuit breakers instead of fuse? Circuit breaker is circuit breaker is resettable. It is faster in operation. It is better discrimination and adjustable protection in higher ratings. Resettable means fuse is not resettable. You know, a fuse contains a metal wire that melts when current exceeds its rating, so you can't reset it. Once it blows, it must be replaced. Only you have to replace the fuse. Require a spare fuse and manual replacement, so and it causes longer time. If you don't have the fuse, you have to arrange for the fuse. If you have the fuse, you need to replace it, and spares need to be maintained for fuse for each and every fuse according to their rating, so it takes a longer downtime sometimes. No, for circuit breaker trips just open the contacts when it detects overload or short circuit. After clearing the fault, it can simply be reset. There are two mechanisms. It gets reset automatically or manually. No replacement parts needed, and reduces maintenance cost and downtime. So you don't have to replace anything, and you don't have to wait for breaker. You just need to clear the fault and reset the circuit breaker. Because in industries downtime is very expensive, so resetable production improves reliability and operational continuity. Now faster operation. Protection speed is critical during short circuit. Fuse is very fast in high current, especially HRC fuses are very fast. But performance depends on type of fuse and magnitude of current. Okay, it is not adjustable. So only one rating of fuse comes. Either it's 2 ampere, 4 ampere, 6 ampere, 16 ampere. You cannot adjust the fuse rating in current rating in a fuse. Now, what is the advantage of circuit breaker in this? Modern circuit breaker, especially MCBs, MCCBs, ACBs, uses thermal protection for overload current and magnetic protection for short circuit current. So magnetic trip mechanism acts almost instantaneous during the high fault current. So the magnetic trip mechanism is as equal as the fuse. It just trips in the milliseconds. So there was a faster operation challenge with the circuit breaker is also now resolved with the magnetic protection. But why faster operation is needed? It reduces equipment damage and limits arc energy. As soon as it is extinguished, the arc energy does not increase. Now third is better discrimination. Discrimination means only the faulty section should disconnect, not the whole system. So in fuse, it is difficult to coordinate precisely. If ratings are not properly selected, multiple fuses may blow. Like if only 2 amperes are connected in series, so all those will blow. Or a rating mismatch happens. So in this case, less flexibility in graded protection. It will not give the better flexibility. Now, circuit breakers, as you know, it is adjustable time current characteristics it has. So can coordinate upstream and downstream breakers. If you have two or three breakers, it can coordinate upstream and downstream breakers. So the breaker near the fault only trips. So in industries, mostly circuit breakers are used. Now, adjustable protection in higher ratings. So again, there is no major advantage in fuse have fixed rating and cannot adjust. You cannot adjust the current rating in fuse. In circuit breaker, you can adjust. There are many settings in the circuit breakers, especially in MCCB and ACB, not in the MCBs normal. But in MCCB and MCB, you can adjust the long time overload setting, short time delay, instantaneous trip current, ground fault protection, and sometimes there is electronic programmable curves also. So long time overload means sometimes a motor gets overloaded, but in that case till the preset time the circuit breaker will not trip. Suppose there is 100 suppose a motor draws 100 ampere of current and it is drawing 110 ampere, so circuit breaker will not trip instantaneously. For a preset time it will allow the motor to draw, because this happens sometimes. So similarly, short time delay, instantaneous trip current set to trip the circuit breaker instantly when there is a short circuit. So why this is matters in MCB? Because protection can be fine tuned to actual load, not not to the fixed, just like the fuses. So what are the advantages of circuit breaker? You can see can act as a switch. It can act as a switch also for on off, provide clear fault indication, can integrate with remote monitoring, also automation system, smart grids, higher braking capacity in advanced models. So now more advanced models are coming with higher braking capacity. Still, there are some places where fuse can be used. and recommended where to be used. Here the cost is low cost for small applications, very simple in design, no moving parts, and this is extremely reliable for small domestic circuits. Still, in some homes, we use fuse only. And one for small sensitive electronics. So very high speed protection for small sensitive electronics. So these are some of the benefits of circuit breaker instead of fuse. Now classification of LT circuit breakers. So anyone working in industry might know. Just let me change the pen color once. Okay. So based on application, there are many miniature circuit breaker. We call it MCB. Molded case circuit breaker we call MCCB. Air circuit breaker we call ACB. Residual current circuit breaker we call RCCB. And there is new technology come RCBO. So this is a mode of application. Now based on arc quenching. So air is the medium. When air is the medium in arc quenching is to extinguish the arc. So we use MCB, MCCB, and ACB. These are air is the medium for arc quenching, and vacuum in some LV circuit breakers. Basically, vacuum is used in ST circuit breakers, like vacuum circuit breakers used in 11 kV lines and above, or sub-6 circuit breakers used in ST lines. Now, what is miniature circuit breaker? MCB. Its construction involves a bimetallic strip for thermal protection and electromagnetic coil for magnetic protection. Arc shoot and arc shoot. What is the operating mechanism? So, bimetallic strip used for thermal protection. Breaking capacity of an MCB is the maximum fault current that the MCB can safely interrupt without getting damaged. Okay. Now, what is the working principle of? You can see there is a bimetallic strip here. Under magnetic coil, you can see that this is a magnetic coil. This is the contact, and this is a cable terminal. This is out, and this is in. So you connect the cable in this spot. Now how it works? So this is a strip made up to different metals bonded together. Generally it is brass and steel. So under normal conditions, normal current, it is straight, it is straight, it stays straight. Now what happens during overload? Excess current cause heating of the strip. Now because the two metal expand at different rate, the strip bends. The expansion of brass is different and steel is different, so which causes the strip to bend. This bending pushes the trip mechanism and opens the circuit. So this bending pushes the trip mechanism. and it opens the circuit, and in circuit the arc should is the air. So air is the medium to extinguish the arc. So it works on the principle of thermal effect of current, operates with a time delay, and protects against overload conditions. Now, trip characteristics are trips at 3 to 5 in residential, 5 to 10 seconds in commercial, and 10 to 20 in motor loads. In what rating the MCB comes? It comes in 0.5 to 125 ampere. Uh, Higher than 125 ampere, it, we need to use MCCB. Now, now how short circuit? Now you have seen how overload protection is captured in this. The metallic strip melts and it opens the circuit. Now, how it protects the overload? So you need see there is a solenoid coil with a movable iron plunger. Under normal condition, magnetic field is weak. Okay, during a short circuit, current suddenly becomes very high. So strong magnetic field is produced instantaneously. Change in the current produces magnetic field. You know that. So under short circuit, current changes very high. So strong magnetic field is produced instantaneously. The iron plunger is pulled rapidly. Due to this generation of magnetic field, the iron plunger is pulled rapidly, and this trips the mechanism immediately. So this is the mechanism how it is tripped in short circuit. So what is the importance of MCB? Prevents damage to contacts, improve safety, increase breaker life, and is after clearing the fault, it is also reset up. You can see this is operating plunger, operating lever. This gets tripped. If this is normal condition, this comes this way. Just need to reset, so we can use it again. This is manual mechanism, and we have to on it on it manually. Now for higher ratings, this is point for up to point. Generally, we use up to 100 ampere or 125 ampere MCB. For higher rating, we use the MCCB. MCCB is the construction involves molded insulating case, thermal magnetic or electronic trip, arc chamber, and contact, fixed and moving contact. It provides protection against overload, short circuit, earth fault, and under voltage. This is the optional. You There are settings in this and adjust, and this MCCBs are totally adjustable. So what are the functions of circuit break MCCBs? So it electrically insulate internal parts, protect against dust, moisture, and this molded case. Why this molded case is used? It protects against dust, moisture, and mechanical damage, and provides mounting structure designed for higher current ratings from 16 ampere to 1600 ampere. Now again, there are two mechanisms. Current range up to 100 ampere to 2500 ampere, breaking capacity up to 1000 kilo ampere, adjustable long time and short time delay. Applications are industrial feeders, motor control centers, generator protection. So now we will discuss this in detail. So this is the basic structure of MCCB. It's movable. You can see movable contact, guide track, insulated plastic, cam, a rotating shaft, PMA, and movable iron. Because two mechanisms are involved. One is thermal magnetic trip and electronic trip circuit. Again, thermal part bimetal overload protection, magnetic part coil short circuit protection. Used in all industrial and high power systems. Now this is again a air circuit. Arc chamber is arc chute and air is the medium for extinguishing the arc. So uh, when the contacts are open, the arc forms. Arc enters the arc chamber. Metal splitted plate divides arc and arc cools and extinguishes. Okay, the mechanism for magnetic and the mechanical mechanism for thermal and magnetic is same. Like in thermal, two different types of metals are used with different heating capacity. When the current increases, metal heats up and it opens the contacts. Same with the magnetic coil. When a certain inrush of current happens, magnetic field increases and which pushes the iron plunger to open the contact. So operating mechanism is same. Some advancement is with adjustable, like it has adjustable long time and short time delay of breaking. Now air circuit breaker. So its constructions involve main contacts, arc runners and arc chutes, electronic trip unit and drought mechanism. Working principle, it uses atmospheric air to extinguish the arc. Now main and arc divide into smaller segments in arc chute. So main contacts. So what are carried in the main contacts? Main contacts carry normal current and open when a fault occurs. There are arcing contacts separate after main contacts and handle the arc during interruption. There is arc extinguishing chamber in this. It splits and cools the arc, extinguishes it using safely during atmospheric air. If you have seen air circuit breaker, it is either operated manually or can be used by the lever. So you can see here, this is the lever. You just need to charge it down and the a breaker make the contacts, or there is a motor in it that charges the circuit breaker. So what is its trip unit consists of it detects the overload, short circuit or ground fault, send signal to trip the breaker. Now what is the working principle? Under normal conditions, okay, current flows through closed contacts, you can see. Under normal conditions, when current flows through closed, when a fault occurs, the trip unit detects abnormal current. It activates the opening mechanism. Contact gets separated and arc forms. The arc enters the arc chute. So here we see the arc chute. It is split into smaller arcs and cooled and extinguished by the air. That mechanism is installed in the breaker, and the braking is handled safely, and the arc is interrupted. No, protection function. It protects long time delay, long time overload delay, short time delay, instantaneous short circuit, earth fault, zone selective interlocking. So long time delay again said that for a certain time, if a equipment draws a more current, it will not trip instantaneously. For the set time, it will allow the equipment to draw more current. Short time delay, instantaneous short circuit, like in the event of short circuit, it trips the mechanism instantaneous to prevent any further damage of the earth fault. When a cable damage or leakage is observed, it break the circuit. Zone selective. Zone selective means if there are multiple circuit breakers, they are programmed in such a way that the breaker near the fault breaks up the first. So this interrupts the working of the uh, industry. That overall the main breaker does not trips. Main and the breaker near the uh, fault, it breaks first. So what are the current ratings? It comes in 800 ampere to 6300 ampere. In industry, it is used as main incomer, with bus coupler and generator breaker. Now, there are certain types of circuit breakers. Plain breaker, plain break ACB. Simple arc interruption in air. In that simple arc interruption, air in air. Magnetic blowout air circuit breakers. Use magnet field to move arc. Air shoot circuit breaker. Uses arc shoot plates to split arc. And air blast circuit breaker. Use high pressure air. So this is used mainly for high voltage, and these are very less common today. What are the advantages of air circuit breaker? So the simple construction, easy maintenance, no fire hazard, no oil in fault, suitable for frequent operation, and good for industrial and distribution systems. Disadvantage is that this is larger size as compared to MCCB, and arc interaction capacity lower than vacuum and SF6, because so that is why they are used in high tension vacuum and SF6. Now next is residual current circuit breaker, RCCB. In this phase, a neutral current passes through toroidal core. So first, what is RCCB? What is residual current circuit breakers? So an RCCB is a protective device, okay, that disconnect the circuit when it detects leakage current to earth. So when any cable cut happens, or anything that makes the leakage current to earth, when you sometimes when you touch any equipment and get a sudden shock, that is because of the leakage current. So in that case, it is the function of RCCB to trip the circuit, so to protect the humans working there, so to protect the people from electric shock and any kind of fire risk. So what is the working principle? So both live and neutral wire, phase and neutral wire, passes through toroidal ring shaped core. You see there, you can see both phase and neutral passes through the toroidal ring shaped core. Upper is the line, and lower is the, they act like the primary winding of a current transformer. When you see a current transformer, you can see this looks like the primary winding. And what comes of the secondary winding of the current transformer? You know, under normal conditions, net current is zero. Current enters through phase current, returning through neutral under normal conditions. So current entering through this phase and going to the load and returning through the neutral. Magnetic field cancels each other. This for this the magnetic field produced by this and this cancels each other, so no flux is induced or no trip. Okay, now under leakage condition, imbalance occurs if current leaks to earth through human body or fault insulation. Phase current will no longer be equal to neutral current. No residual current flows. So there is a net residual current which flows because the magnetic field changes for both phase and neutral. Magnetic imbalance induces the voltage in secondary coil. Now this is the magnetic imbalance induces in secondary coil. This is a secondary coil and magnetic imbalance induces in this coil. So this activates the trip mechanism and RCCB disconnects system supply instantly. So this activates the trip coil and the circuit gets disconnected. So sensitivity ratings, it comes with 30 milliampere. Human protection prevents photoelectric shock. It is for human 30 milliampere is the limit. If it is more than 30 milliampere, there will be shock and may cause a permanent damage to the human. 100 ampere against fire protection and 300 ampere in larger installations, for fire protection in larger installation. The important note is that does not protect against overload or short circuit. Must be used with MCB. So never. So this should be kept in mind that it does not protect against the overload or short circuit. RCCB is only protect against the leakage current. So it must be used with MCB or fuse for complete protection. There is a test button. You can see in the orange color. There is a test button. So test button should be pressed periodically to ensure proper operation. You have to check, and these are very important in industries. Now there is residual current. Sorry, this is residual current RCBO. What is the full form of RCBO? Residual current breaker with overload protection. So it is a combination device that integrates the function of MCB and RCCB. Earlier, what we said that we need RCCB cannot alone work to protect the overload or short circuit. It is only for um, leakage current. But RCBO, it is the advanced version of RCCB. It comes with a combination of MCB and RCCB. So in this MCB part is used for the protection of overload and short circuit, and RCCB part is used for the protection of leakage current. So all in one single unit. So it protects against overload, short circuit and earth leakage. So what is inside the RCBO? Again, if it is protecting against the overload and short circuit, so there must be thermal element. So thermal element trips during overload, magnetic elements trip during short circuit. The mechanism is same. Thermal element, two different metals, two different melting points. So when it heats up, it trips the circuit. Magnetic element again connected with an iron plunger. When heavy current flows, the magnetic field increases and it activates the plunger and trips the circuit. So mechanism is same, only the structure, the advancement is different. Toroidal core detects earth leakage current, same like the RCCB. So one part one part acts as the MCB and the other part acts as the RCCB. Trip mechanism is disconnect supply when any fault occurs. Then RCBU protects against overload, short circuit, or earth leakage. Now, what are the advantages? Say panel space. You do not have to place one MCB and one RCCB. Only place one RCBU. So, save panel space. Individual circuit protection. Each circuit has its own leakage protection. Generally, we use RCCBs where not with every MCB we use RCCBs. Where there is manual, uh, in, when the person is working nearby that devices, like give you an example, in fabrication industry we use RCCB on the panels from where welding machines are connected, because that machines are usually generally in touch with the persons working there, so they should not get any kind of leakage current. In this case, is protect individual protection can be provided to each and every circuit. Reduced nuisance on tripping. Fault in one circuit does not affect others. Okay, and better isolation. The common rating of circuit breaker is from it comes between 6 ampere to 63 ampere. Sensitivity is again 30 milliampere is the standard sensitivity. Now there is some comparison given between RCBO and RCCB plus MCB. So overload protection, yes, both in this combination it can be done with MCB. Short circuit protection, it is done with RCBO, but here it is done via MCB. Earth leakage, yes, is done via RCCB. Panel space, in this it is compact, more space required because you have to place two equipments, one RCCB and one MCB. Cost slightly higher because it is modern technology. It saves your space. It provides individual protection. If you go for RCCB, MCB may be lower, but all in all, it will be almost same only. There is no very much difference between the price. So these are some common difference between RCCB and RCBO. So generally now we are using RCBO only in some critical applications. I think that now comparison of LT circuit breakers. Okay. MCB, MCCB, ACB, RCCB, and RCBO. Current range MCB is low, MCCB is medium to high, ACB is very high from up to 2500 ampere. RCCB and RCBO are low because they are used in smaller panels where the direct equipments are connected. Overload protection MCB yes, MCCB yes, ACB yes, RCCB no, RCBO yes because it comes with MCB and RCCB. So, and MCB helps with overload protection. Earth leakage protection MCB no, MCCB optional. You need to make the setting accordingly. Same with ACB. You need to do the setting. RCCB yes, it is made for earth leakage only. RCBO yes. Breaking capacity low for MCCB high, for ACB high, that for medium and high. That's why they are used for higher currents. RCCB low, RCBO is medium. Application MCB used in homes. Every home you see MCBs or fuses. MCCB and ACB are used in industry in main panels. Generally in ACB used after the transformer and in your LT panel in the industry. There is one main ACB connected with different MCCBs and CBs for the local protection, and main is the ACB. RCCB is used for shock protection by discontinuing the circuit from if there is case of leakage. RCB again, home and offices application is same, shock protection and flood protection. So what is the conclusion of this video of this LT circuit breakers? LT circuit breakers are critical for electrical safety, equipment protection and fire protection. Selection must be technically calculated, properly coordinated and as per standard. Technically calculated means that the setting of the current setting must be made according to the equipment you're using, not too high or too low. Too low will cause the nuisance of multiple tripping, and too high will not allow you to trip in case of overload. So it should be used with precise calculation. What is the overall working current of the equipment? What overload capacity need to be fixed so that it helps in protecting the equipment being used. So properly coordinating means if you're using 2 3 circuit breakers, the breaker near the fault should trip first, not affecting the entire working system. So for now we need to conclude. So these are some basics, some operating mechanisms and types of circuit breakers. So we'll try to get with some new things in the next video. So do like the video and subscribe the channel. Thank you.